Okay, so let's look at those flowers. Flyers. Flowers. Flowers don't usually fly. So let's look at bats first. Why bats? Well, I have to say bats are sort of the quintessential dragon wing, which makes them pretty important. A bit of review here. So if you look at our normal hand bones here, you can hold your hand out actually and start thinking about like where those segments go. A bat has a fairly normal hand just with the elongated fingers and hand bones that support it. One thing that I think is interesting and people don't often think about is that bat wings are not just supported by the fingers, they're actually the whole hand. Notice the purple bones here, those are like the hand bones or metacarpals. And that's important because, for example, in pterosaurs, those metacarpals are actually part of what makes a segment of the wing. And they only use a single finger. We'll get to that later. And birds, of course, use the metacarpals and the shortened fingers to support the feathers. But bats, they actually stretch that hand out, and kind of the webbing between the hands is the hand bones is like a majority of the wing. And then, of course, the finger bones support the rest of the wing. So real quick review, you have a thumb in bats. It's kind of important. It helps actually control this leading edge flap here. And then you have four fingers. There's really no reason you couldn't have a fifth if you're designing a creature if you want to space these closer. But of course, there's no reason you couldn't have less of these fingers. You know, pterosaurs only use one. And I only bring that up because everybody who does a dragon apparently feels that it's like a unwritten law that they have to basically duplicate bat wings exactly. Now, there's nothing wrong with bat wings, but I do think it's important that people realize that you don't have to like stick with the exact same number of veins of fingers in here. So you can get a little variety that way. It's just a pretty rendering of a bat someone did. Okay. A few things about bat wings that I want to point out. The big one is there are generally not holes in bat wings. If you look at actual bats flying, holes are bad. In fact, holes don't really happen. Usually if the wing is damaged, because it's a skin membrane with quite a bit of connective tissue in there, it tears. And if it tears, the animal doesn't fly. It gets, shall we say, really hungry until it heals, or it just doesn't make it. And not making it is a pretty common thing. The other thing about this is since the wing membrane attaches to the hind limbs in these guys, most of them are not very good at getting around on the ground and don't have the easiest time getting off. In fact, here I have an example for you. This is the best brown bat there is. This is a vampire bat running. Yeah, Ishana. I can go ahead and get some of these images as references. So this is a vampire bat on a treadmill. You'll notice how he's like chunking along there and how his forelimbs actually, I don't know who that dude is, actually do a whole lot of the actual moving. And this is important because they can actually hop along at a good clip like that, and they actually can take off by pushing off from their forelimbs, something we're going to see again with pterosaurs in a bit. But the other reason this is cool is because, you know, all too often when people come up with winged animals, they try to do the whole wings are like bat wings, except they're not really attached to the body, so our dragons can run around as fast as they want on their hind legs. And that's probably not realistic. Now, you have seen some great examples of people not doing this, and this is one area where the dragons from Reign of Fire were really awesome, was they went to great lengths to make their ground movements more constrained by their wings, and that was really fantastic. The other thing I want to note is bats actually still have pretty short bodies. Now, if you look at this image, you might be like, that's kind of long, but really the body starts here, because they do have little bitty necks there, and ends, of course, here, because those are the hind legs out behind them. So by mammal standards, they have quite short bodies, and they actually have really quite stiff bodies. Not quite as stiff as in birds and pterosaurs, but for things that evolved from little scrambling around in the trees, flexible, long-backed critters. These have really short, really stiff backs by mammal standards. And again, notice there are no actual tears. Even this is not actually a tear, it's just a weak point there. So many dragons have holes in the wings. Please don't do that. I realize it looks cool, but it also looks like the animal cannot get off the ground. There really shouldn't be holes in an animal that can functionally fly. And if you have a dragon hunter movie, don't go for the neck. Go for the wings of those flying dragons. That's definitely the best way to get them. Yeah, actually, for those of you who have seen, was it How to Train Your Dragon? Was that the name of the DreamWorks film? That was like the most realistic part about that film is that, and I don't know why I took an animated cartoon for this to come out, was they're like, you know, go for the wings. Once you hit a dragon's wings, it's dead, which would totally be true for any real dragon, as it is largely for bats, and probably was true for pterosaurs. Okay. So, quick bat summary here. Bat wings are the de facto flying wings, which is okay, but please don't do it as an automatic knee-jerk response. Do think about pterosaur wings when we get to them, and do think, if you are going to use bat wings, about coming up with a solution that doesn't use the same number of fingers, for example. Something that makes it a bit different. Second, I know I'm beating on this, but I really wanted to end, and you guys must go out into the world and spread the gospel that bat wings don't have holes or tears if they're functional. And if they do have holes or tears, it's not going to end pretty for them. They're certainly not going to fly around and breathe fire on people's villages. So dragons with holes in them, bad idea. Really even worse than bats with holes in them. And then finally, bat wings, of course, connect to the body, and frequently in some species actually down to the hind limbs and even onto the tail. And that's, of course, because bats came from gliding ancestors. Dinosaurs, on the other hand, managed to do it completely bass-backwards. And for that reason, there are lots of dinosaurs with feathers, and even lots of dinosaurs with wings, that not only didn't fly, not only didn't glide, but really couldn't even get up in a tree, like this tubby guy here. This is a therizinosaur with elongated quill-like structures on a true proto-wing. It actually would have probably come down the hand, too. Here's a Deinonychus. Actual wings, might have even used it to leap onto prey, but certainly wasn't gliding anywhere in particular with it, and probably wasn't going up in trees much at all. And if it was going up in trees, it wasn't going up them so that it could glide from there, because it just wouldn't have had the glide ratio to get anywhere safely. Another series of basal oviraptors. These are omnivorous dinosaurs. You can kind of think of this as dinosaurs trying to be a cross between a pigeon and a rat. These are kind of like generic, find them everywhere in the forest, small, feathered ground dinosaurs. They don't fly, they don't go up trees, they don't glide. But they definitely had wings. This is the kind of thing that dominated much of the Cretaceous. By the way, if you are going to do animals with wings, this is a really underutilized idea, this whole animals with wings used maybe to help turn or help display or do cool stuff on the ground. And you could do this with let's say you wanted to come up with a ground creature and give it sort of bat-like wings, but don't connect the wings to the body that didn't come from gliders. That would be a fun thing to do. You could totally give them fingers that worked most of the time, but when they spread out, just had like proto-wings on the very end and didn't connect. And those would be animals that wouldn't go up in trees and would have kind of a bat-like wing set. So that would be kind of fun. Maybe they could knuckle walk when they're running or something otherwise. Yeah, display as in trying to attract mates like in peacocks. I don't want to give away the whole thing. I have some papers I've done on this and I'm doing later. Dinosaurs aren't as good at turning. Their hips are a little stiffer in the back, unlike the ball and socket joint that everything else on the planet has that often allows for pretty good turning up at this joint. They're pretty much stuck with just fore and aft motion up at the hip. And so they get a little bit of motion at the knee and a bit more at the ankle and quite a bit on the toes. They still don't get as much overall rotation for turning as, say, people do. Now, four-legged dinosaurs, it's not really a problem because four-legged dinosaurs have forearms that can help push to turn. But dinosaurs that were on two legs either had to have big tails to kind of help them like flick around and rudder into turns, or else they probably had to push against the air to some degree. And that's, I think, why all these wings are so terribly common in these ground-running, non-tree climbing winged little dinosaurs. Oh no, yeah, they worked great for pushing against the air and helping these guys turn when they weren't good at turning. They simply weren't good at gliding. The problem is, do I have that image in here? There. The thing is, you're thinking of it like this. You're thinking, why did they acquire things that weren't useful before they could fly? And the thing is, they weren't useful for flying or gliding, but they were useful for other things first. The key is to understand what they were useful before they got to the stage where they could do that. For example, at this stage, it keeps you warm. And that's a pretty good thing. Lots of animals that don't fly have solutions to keep them warm. Hey, Roman. So yeah, here's another thing that was useful. Once wings get to a certain size in some of these dinosaurs, maybe not even this big. These are baby birds that can't yet fly very well. This is the adult, but the baby ones that can't fly can still do this. They actually can flap their wings harder upwards to stick them to vertical or almost vertical surfaces so they can walk it up. It's kind of like if you ever watch race cars, like Formula 1 race cars, where they have spoilers on the front and the back of the car to stick the car to the road. This is kind of the same concept, but with active flapping, where you're sticking yourself up to a substrate you couldn't otherwise actually walk. So the downward motion generated by the upwards flapping is sticking them so they can otherwise literally walk up or run up the slope with their leg muscles. And this can be done by animals that can't fly. So dinosaurs, which don't really show any particular adaptations for climbing, at a certain point, were able to get up trees by getting small enough and having big enough wings and a big enough motion of those wings to simply walk up the trees, which would have opened up a huge range of new ways for them to explore. And that's a fun idea too, by the way, if you want to design a cool creature, even again like a bat-like creature that we're talking about a hypothetical knuckle walker with wings, that membranes that would stretch out when the fingers are stretched out or something. You know, it maybe could show off. And maybe one of the uses for them would be, even if it were four-legged animals, when it was going up the tree, it could perhaps flap up and then walk up the tree. This is, by the way, it's called WAIR, W-A-I-R, or Wing-Assisted Incline Running. And it's something that probably all birds can do, but it's very common in the most primitive living birds today, that a lot of them, when they're juveniles and can't fly, will use this to like escape from danger. And probably is something found in a lot of the more advanced winged dinosaurs that were small enough and had a advanced enough shoulder girdle to let them do it. Definitely a cool idea if you're looking for some sort of new design concept for a creature that people don't usually see. And of course, by the time you get to this phase, you can't really see the wings so well at this resolution. It has wings here, it also has wings on the hind legs. By the time you get to this phase, or to a Microraptor phase, you get to animals that can not only wear up trees, but could actually glide quite nicely, and maybe could even fly. I don't know if I believe that they're gliding to other trees personally, but a lot of people draw them that way. But remember, these guys got here by going through essentially all the other phases without being up trees, and that's why their wings look incredibly different from everyone else's wings. That's why all the early wings start out on the outside and grow in like this. The other thing that's neat about this is it explains why, yeah, there's feathers on the tails from pretty early on, Sean. It also explains why a lot of features you see in dinosaurs, like the avian-style brain, in the shoulder, they start modifying the shoulders to allow wings to get higher. There's a lot of things that are very bird-like that happen in animals that cannot fly. And what's nice is it actually explains why those things are changing. We call them pre-adapting, but what they're really doing was becoming useful for what they're already doing on the ground and eventually maybe running up trees. They had to kind of develop the same solutions to do that, and then by the time they got to a phase where they could glide, they were already there. Like their shoulders and backs and hips and brains and stuff were already developed to allow that sort of motion. Of course, true modern birds show some really interesting adaptations. Modern birds, for example, have lost all their teeth, so people tend to like assume that beaks and teeth don't go together, but it's worth noting that like there were plenty of flying early birds that did have both teeth and beaks, sorry. Modern birds can fold up their wings incredibly tightly, but it's worth noting that like for a huge stretch of time, dinosaurs with wings could fold up their wings, but not as tightly. Modern birds also have incredibly short torsos. This is actually the ilium right here. So from here to there is the torso. And they're incredibly stiff. They tend to pack as many vertebrae as they can into the hips. They also use this massive, of course, here's the wishbone hiding up in there. Here's where all the white meat is on your turkey. They have these massive pectoral areas to pull down. In fact, they do this more than any other flying animals. Bats have big pectoral muscles, but not nearly as big as these guys do. And partially, I want to think that that could be because of the wing structure. I won't go into the various arguments as why it is, but notably, the hind legs are totally separated from the flight structure in modern birds. And that's, of course, again, because they didn't come from tree gliders, at least not for most of their history, not until right towards the very end. And so they don't have this flight apparatus. Yeah, that's the keel and the sternum there. The actual internal guts just only go down through here. This is the chest, but then there's all this massive area that the keel creates that muscles go for pulling the wings down on. I should also, they do funky stuff with their deltoids. Everyone thinks of the deltoid as kind of being above the wings, and indeed some of their deltoids are, but they have muscles that run from like around the coracoid, the supracoracoideus, and some other muscles from up here where that is that actually kind of loop over the scapula before they insert on here. And that allows them to, when they flap the wings up, actually twist them. Because I didn't go into this in too much detail here, but animals that fly don't just flap their wings straight up and down. They kind of twist them up as they come up so that they don't flap themselves down, if you will, before turning them again and then flapping down. And that's an important motion if you're going to model an animal. Most of the time that motion is going to matter to your rigger and your animator if you're working in a pipeline. Yeah, but if you are going to like sculpt an animal taking off and the wings are going up, you don't want to have the wings be perfectly horizontal. You want to have the front edge aimed up a bit as they come up. It's actually more like a swimming motion if you want to visualize it. Okay, so there you go. That kind of explains flying dinosaurs as we think of them today and the not-so-flying ones. Remember, keel, all that pectoralis, and it can like go right up here to the wing that would be attached here and pull it down. Also, you can think delicious if you want to guess. There's the thighs. One thing I would also note before we go on, that most flyers have really quite short legs. Birds sort of follow this. If you think about how deep the body is here and how the knee is hidden all the way up there, that's really because birds are, again, hiding a lot of their leg and their muscle up here. So even though some birds, like shorebirds, have really long legs, they do it just by elongating the lower sections. Most of the beefy parts of the legs are always up, tucked really close to the torso, and that's because non-flying parts that are heavy are best kept close to the body for aerodynamic reasons. Yeah, ones that no longer fly, of course, don't have to follow these rules, and indeed they don't. Okay, so quick review of birds before going on. And of course, I'm interjecting dinosaurs because we have both flying dinosaurs, which is modern birds, and then we have winged dinosaurs that weren't flying. But sorry, Fredo. Dinosaurs, in their history, spent a heck of a lot of time with wings, doing a whole series of things on the ground that was not flying. Which means, even though you maybe shouldn't use feathers, because as we talked about in week 1, feathers are kind of a no-no, or week 2, feathers are kind of a no-no for alien worlds. The idea of coming up with winged animals that live on the ground is totally okay. You just have to think of what they're doing with those wings, and you also have to remember that changes where the wings emerge. A ground-dwelling animal with wings needs to do something that isn't gliding, and it needs to not have a wing that's attached to the body the way most gliders do. As an interesting fact, maybe just to make you feel sadder about not being able to use feathers or not being supposed to use feathers, bird wings, dinosaur wings if you will, are actually far more durable than bat wings and probably pterosaur wings were, because even though feathers are individually easier to damage, the loss of a feather is not catastrophic. One other advantage actually for dinosaurs is because the hind limb is not in any way integrated into the wing, birds often can combine being pretty active and fast on the ground with still flying, and that can be a real advantage. You know, a bird who can't fly isn't just stuck on the ground going, gosh, I hope no one finds me. It can walk away and hide, and if it's found, it can at least attempt to run away. Um, yeah, as a quick note, I kind of mentioned this earlier, but dinosaur flight kind of requires feathers, as we're talking about here, and unfortunately feathers are a no-no. So if you want to adapt these, come up with a cool way to have wing membranes at the end of your limbs or something. Okay, interestingly, and this might be again related to all the time spent on the ground, but birds really, really emphasize the pectoral muscles. They really hypertrophy them. And they make the deltoids odd. The deltoids don't work exactly the way you would expect them to, like in a bat, the way they do work in a bat. But that's why, you know, birds are always going to be better for domestication. We could domesticate bats and try to make them all plump, but we would never get all that juicy breast meat that everyone loves, so they can eat it and stay trim and have lower fat content. It's just not going to happen. And so that's an odd thing of birds, and I don't know that I recommend it, actually. It's an okay solution, but you'll notice, and we'll show you later, several people solve trying to make, say, griffins or dragons fly by giving them incredibly deep, incredibly massive bird-like sterna. And I'm okay with that, but it's not necessary. There are other ways you can bulk the arms up with the deltoids and spreading the pectoral muscles more up over the ribcage and stuff. Birds, however, like bats, shorten and reinforce the torso. In fact, they do so even more. Part of that is relating to the breathing in the air sac system, but due to the rigors of flight, it was always going to be short and stiff, because when you flap your wings, you can't have it go flexing your back and moving your hindquarters apart. It's just not going to be an efficient way to fly at all. Okay, I'll go to pterosaurs. I should actually stop real fast. Are there any questions about this? I covered a lot of stuff there with those dinosaurs. Does anyone have a question before we delve into their flying cousins?